Hey guys, I'm gonna go ahead and try this via video here. Today we're gonna go ahead and do volume day 2. And it's going to start with the disc, and we're going to talk about something new with the washer method. So our first thing I want to do is get you an idea what the washer method is. I have a quick video that kind of illustrates it. Okay, do me a favor, don't make fun of me. I'm going to make a lot of mistakes along the line here, but be easy on me. So this guy's got a video of root x, 1/10 x, and 4 all graphed. And actually, if you were to take that region, and I think he does it in red here, and he's going to rotate about the x-axis. Pay close attention to the gap that's along the x-axis. It actually creates this hole inside this washer, and if you were to take a chunk of it and kind of take it out and look at it, we have a circle, kind of like a disc method, but it has this hole in it. That's why we call it the washer method. Now, if I wanted to go ahead and find the area for this washer, you can kind of figure it out that the area for the whole thing minus the area for this small circle here would be the area for this washer. So pi r squared is obviously the area for a circle, and you're going to subtract the small circle. So a big circle area minus the smaller circle area. That is the basis for the washer method. But what we do is we make it a little bit simpler. So this is the washer method. It's really pi r squared. So we write a capital R for the big radius minus the little circle, and we'd integrate that. But because pi is listed in both of them, we could take that out as a GCF. And so we have this very convenient big R squared minus little r squared with a pi out front, and that is our washer method. So I'm going to go ahead and give you a sec to write that down, but we're also going to include some really important notes, and you can pause the video after this, but this is really important. Whenever you rotate about a y equals line or a horizontal line, you always have to integrate with respect to x. So if I rotate around y equals 2, the x-axis, any kind of horizontal line, it needs to be with respect to x. If I did it around any x equals line or a vertical line, say x equals 2, x equals 3, or the y-axis, then you have to do it with respect to y. You can go ahead and pause the video because this is going to be really important for you to write down. Okay, so our first problem we're going to go ahead and try to do with a calculator, and very much what you'd think you'd have to do first. They give you a couple of equations, and in order to find volume, we need to first figure out what the area looks like. So we have this y equals x squared minus 6x plus 11, which I believe is some kind of parabola like this. And if you did y equals x, you get some kind of diagonal line like that, and x equals 0 obviously is that vertical line. So you can tell that this area in here is the area we're talking about. Now if you rotate about the x-axis, the way I illustrate that is by doing kind of a circular arrow there, and that's going to rotate it around, and actually it flips it around over to the below. Let's see if I can try to draw that kind of nicely, and you're going to get this three-dimensional image with this like hole in the middle. And here's the best way I can do it. I know it's not very easy, but you can get it from the right side. You can kind of see, okay, this red region has this blue hole. It kind of goes indented, and the best way to see that is from the left side. You can see that this blue cone on this left, on the image on the right, is just viewing from the left side. That goes in there. I know it's not very easy to see with this image, but this is kind of a three-dimensional picture here of what's really going on. So this is our piece, something like what we have here in the blue here, and if you took that and rotated it around, you're going to have a three-dimensional shape. And since it has this kind of gap in the middle right here, this is going to end up being a washer method. It's going to have a hole in it when we rotated it. So we have the big R squared minus the little r squared with a pi out front. Starts our washer method. So we need to figure out what big R is and little r is. So I always draw from the center of these circles, from the center of rotation. It's always on the axis of rotation. And now if you're trying to find the big radius, you go all the way out till you touch the curve. And actually I could draw that anywhere, but I chose to just kind of put it right in the middle. And so that distance is the distance from the x-axis to the red curve, which is a y value, which the x squared minus 6x plus 11 graph would tell us. So that's the big radius, and I'll square it. Big radius squared minus our little radius. So our little radius now is the distance from the x-axis all the way to the first curve. And that first curve there, when we go to touch that, like that's the hole. Like all in the middle here is all the hole from the when you rotate it, it'd actually be from this left side. It'd be like that, all that blue region that you can see right here. All right, it would find that area. So I find that radius. So if we put that over here, the big radius, little radius would just be y equals x. Throw it together in an integral, and you got your pi out front, and this is your setup, at least, for washer method. The only thing that we have to do left is to figure out your limits. Well, it's very easy to see that you start at 0. They gave you x equals 0. But how far do you go right? Well, you'd go until the two curves intersect. And luckily you have a graphing calculator on this one. You can go ahead and determine this intersection point by plugging into your calculator. I got only a few decimals here, but 2.382. Make sure that you keep maybe 4, 5, 6. 6 would be best. And you get if you throw that in your calculator, since it's a calculator problem, this is as far as you need to go. Volume equals 280.513. And since there's no units, you can say there's units cubed. Cubic units. So we did this whole problem with respect to x, dx. We rotated about a horizontal line, so it needs to be with respect to x. If you notice, your radii go vertical. What kind of values go up and down? Y values. So all your equations are in the form y equals, y equals. So that's good. When we flip this around the other way, you're going to get in the form x equals, then everything has to be with respect to y. So here we are. Next problem, we're going to go ahead and do this non-calculator. Y equals 2x and y equals x squared. So x squared is a pretty standard graph. Got our parabola. And then y equals 2x. You can plot a few points if you want. You can see that my graph looks something along the lines of this. And there's a little sliver there, and I'll make this red, where you've got your area. You're going to be rotating this one about the y-axis. This is a vertical line. So before I tell you if we're going to integrate with respect to x or y, your radii in this problem, they always start from the axis of rotation and go towards the graph, towards the function, towards the area. So my big radius is going to go all the way out to the outside area, and my little radius is going to be the hole, the missing piece. So it's going to be this vacant space in the middle. So these values are x values. They go right and left. So that means all my equations need to be in the form x equals. So we're going to be integrating with respect to y. All of our equations need to be in the form x equals. And that wasn't very obvious until we figured out what it's being rotated about. So to switch our equations real quick, the y equals x squared one's probably the hardest. It'd be x equals plus or minus root y. And our other one, x equals y over 2. And we have to set up big radius squared minus little radius squared with a pi out front. So big radius. Big radius would be this top radii that I have here. Oops, that was this. Sorry, typo. This guy here. And that one is going to be going all the way out to the parabola. So we're going to be using root y in some way. Now, do I use the positive case or the negative case? Well, I'm just going to be using the positive case because that's a positive x value. You're not going to have a negative radius. So root y is my big radius, and then you have to square it for the formula. Minus my little radius. So my little radius, again, is the space in the middle here, yeah. And that goes from the y-axis to the blue equation, because that's the gap, that's the empty space there. So the blue equation would be y over 2. And you're going to square that because of the equation. And don't forget we're doing dy with respect to y. Now all that you have to do is figure out your limits. I think it's pretty clear that the lowest this goes, remember you have to use y values, the lowest this goes is 0. And the highest is going to go, it might be a little bit harder, it's wherever they intersect here. So how could I figure that out? You guys probably guessed it. Take your root y, set that equal to y over 2. You're taking the two equations and you're setting them equal to each other. And why did I choose the y ones and not the x ones? Because I want to know the y value where they intersect, not the x. So here, might square both sides to start. So I've got y equals y squared over 4. Now this could be solved a lot of different ways, but I like getting rid of my fractions. So multiply by 4, and you've got 4y equals y squared. Since this is now a quadratic, get it all over to one side and take out a GCF, which would be y. And you can see that your two answers are 0, let me move this a little bit, and positive 4. Well, we already knew that our one y-intercept was 0. Now our other one's positive 4. And then this is something that we could finish up in our without our calculator by just simplifying up. So root y squared is obviously just y. The second part would be y squared over 4. And you're going to integrate that from 0 to 4. Don't forget to multiply by pi. So I'll finish this problem with you without a calculator and pretend it was a free response test. So y squared over 2 minus y cubed. Now, I already have over 4, and it has to be over another 3. So it's going to be 12. Evaluated from 0 to 4. And don't forget we have a pi out front. We're going to multiply that pi in last. Your answer is just going to have a pi in it. So I'm going to have 4 squared. Well, we'll do that 16 over 2. Minus 4 cubed, 64 over 12. And then you're going to subtract plugging in 0. Well, you're going to get 0 when you plug in 0. And put a pi out front. And this is actually where I would stop on a free response test. So to recap, this one was rotated about a vertical line, the y-axis actually. And so graph your graphs, find where you're rotating, and draw your radii. That's going to be the hardest part, is to figure out what the radii are. If you can do that, I think you'll be okay. Let's try one more before we stop. Find the volume of the solid generated by revolving the region formed by root x, y equals 2, and the y-axis. Another one with the y-axis. So root x, y equals 2, so I'll go up 2-ish, and the y-axis. Oh, sorry, rotated about the y-axis. So in this case, we're rotating about the y-axis. This region here, since it's being rotated about the y-axis, they should probably have an x equals 0 in there just to show us that that stops there. But when this rotates around, you can get an idea that this, when this rotated, is already kind of gap or hole. Okay, when you do this, it's a solid top, or I don't know, kind of a triangular region. There's no gap, there's no hole there. So there's our region. Now what method would I be using? Well, since there's no hole, this is just going to be disk. So this is integrate pi r squared. So r, since we're rotating about the y-axis, starts on the y-axis and goes out to the farthest point of the shaded region, the area. And that lies on y equals root x. Well, if we write that nicely, x equals y squared in the form x equals, you get y squared squared, because the radius is y squared, and then you have to square that. So why am I doing y? Because this needs to be with respect to y. When you rotate around a vertical line and your radii is going sideways, okay, it needs to be in the form of y. Everything has to have y's. So another way of thinking about it is what kind of values go left and right for the radii, and that would be x values. So you need your equation in x equals. Again, no calculator on this one. How low does it go? 0. How high does it go? They gave us y equals 2. So here's our problem. We can actually finish this up pretty easily. This is y to the 4th, right? So if you integrate that, you get y to the 5th over 5. And you got to evaluate from 0 to 2. Multiply by pi last. 2 to the 5th is 32 over 5. If you plug in 0, you're going to get 0. And then just multiply by pi. Okay, we're going to go ahead and stop the video there. Feel free to go back, rewind through this. Let me know if I made any mistakes or if you had any questions. Just shoot me an email.